Welcome, this is Information Service Engineering lecture number 6, putting it all together. In this part of the lecture, Knowledge Mining and Information Extraction, we are connecting directly to our last part of the lecture where we did some data analysis tasks in the form of a collaborative notebook. So, what could we do with the data we have? Just remember, we are gathering data, or we have analyzed data about soccer games. So we had soccer players and we had the height, the weight, the number of goals they scored and other data, numerical and non-numerical data about soccer. So we have put all this data into a Google Sheet, and now we can also make use of this data for prediction tasks. And of course we will use machine learning to do a prediction. And one of the ideas might be, I don't know whether it's possible or not, could we predict the total number of goals of a player from the other data we have? I don't know. Let's see. Okay, so then let's check and try some machine learning on the data we have. Okay, I switch now to a prepared Google Collaborative Notebook. And let's see how it works out. So we have here for the data prediction example our notebook, and we start in the same way as ever. So first we have to set up Python to make sure that we load any kind of library that we need, and to make sure that, of course, we will do also some visualizations in there. We want to make neat plots. So these are the first lines over here. The next part, you already have seen it in the last part of the lecture, is about getting the data into the notebook. And again, we have our data in a Google spreadsheet, and this is the code for directly loading the Google spreadsheet. Remember, if you haven't accessed Google so far, what you have to do here is to authenticate with Google, because Google requires authentication if you require, of course, to read in Google data. Okay. We already did this, so there no authentication will occur, and we will have immediately the data there. And we will see here also, again, what kind of data we are dealing with. So we have already imported the data here into the Pandas data structure that you already know from the last part of the lecture. And what you see here, goals, here is assigned exactly the read in from the Google Sheets, and what you see here in that part is this is the ID of the Google Sheet we are reading, and since it's a sheet and the sheet can have several tabs, usually you have here also the ID of the tab. And what we are reading in is we want to read this Google Sheet as a CSV file, so therefore we have here to specify we want to export exactly that tab in CSV format. So this is how this works. And here you see the first 10 rows of exactly that table that we have read in here. And you see again, we have a row which states or gives us the number of goals. We have a row with a height, we have a row with the weight, then the year, the position, and in case we would require it, the entire birth date. Okay, again, let's have a look at the data. You already know the describe command, and you see the same that we saw last times. So we have overall about 25,000 rows of data, and you see here the mean of the total goals. For example, it's 34, or the mean height, it's 1 meter and 80, and so on and so on. And you see a few statistical numbers which might already give you some insight into the data. So we had this already. Before we can do a prediction task, what we should do, for example, is to see whether there is already some correlation to see between the data we have here. So what we do here in the next tab is we do a correlation, or we compute a correlation matrix, and we want to give out or print the correlation matrix for the total goals. And you see here for total goals, of course, the other, as we already know, the other rows are not really correlated. So it doesn't depend on the weight and on the height, really, how many goals you score. Probably in earlier years, more goals have been scored than in recent years, and this might be related to the case that people who started their career in recent years did not have the chance to score so many goals as people who have already an entire career behind. So this might be the case. So probably it will be difficult, at least to see from that kind of correlation, to predict the value of number of goals we have scored. So therefore, let's take something which might be, let's say, easier or more worthwhile. So I show you here something that we can also look at the correlation matrix for the other values we have here. So what I do here is I insert another code box and I simply here copy that kind of code, and instead of total goals I want to see what's here in for me, what kind of correlation is here regarding the height. Okay, so here I have the height now and I run this, and you see here for the height this is a bit different situation, because as we might assume, the height of course is somehow correlated with the weight. So an easy prediction task could be then to say, okay, regarding the weight, could we predict the height? Let's try that. So what we could do first is we try to have a look at the data, which means we try here to do a scatter plot between weight and height. So on the x-axis, as you see here, we have the weight, and on the y-axis, let's run this first. So this was an old run. On the y-axis, you have the height. And you see here we have a nice cloud, nicely fitted together. And you could imagine, yeah, this might be a good candidate for trying out a linear regression task. And this is what we are going to do. So we try a linear regression to find out or to predict from the height, from the weight, the height. So how does this work in Python? What we do here first, from scikit-learn, we import the linear regression model that we are trying to use. And what we also need is, we want to see how well our task performs. So we also import here the method that is required to compute the mean squared error. So in the line here, you see I simply create a new model, which is a linear regression. And I say, okay, I want to fit in the following data into my data for the linear regression. I use the weights here. And this is only values in reshape, means from the pandas data structure I want to make an array out of it. So therefore then you have here the weight. And of course our labels would be then the height. So this is the linear regression task. I want to predict the height via the weight. If you want to have a look at the coefficients of the linear regression, you can use here the coefficient method for linear regression. And you see here that's the coefficient. So this means this is one of the coefficients of this linear regression. So now we can start the prediction. How does this work? Okay, I assign a new array here with the outcome of the prediction via linear regression if I give them only here the weight. So I want to predict the height via the weight, exactly here. So it's now in a data structure which is called goals height prediction. And what I do here to see them or to visualize it, I do first a scatter plot again of my original data. So a scatter plot of weight versus height. So these are all the scatter plots. And then what I do, I plot also in there the weights according to the height, the predicted height according to the weights I have. So you see here, the x-axis is simply the weight. The y-axis, the things I plot here, is the predicted values. Moreover, what I do then is I compute the mean squared error. So how much deviation is there between prediction and actual output. And since I want to have a closer look at the error, and we saw that it's better here to look at the root mean square error, I do here the root of the mean square error, and we see it then computed here, and I print it out. So let's compute that, and what we see here is, again, here is the scattered plot of weight versus height. This here is the linear regression line that has been computed from the prediction task. And as you see here, the root mean square error is 4.29. So what does this mean? This means that given a specific weight, for example 80 kilograms, our prediction of the height for that weight, at least for soccer players that are listed in Wikidata, deviates in the mean by 4 centimeters. And that isn't so bad, isn't it? So it's quite well, I guess. Okay, so we can also see, actually, we compare now prediction against actual outcome. So what we do here, we print out the first 5 predictions of our array that you see here. These are the first 5 predictions, and we compare them with the first 5 labels that we have in the data, and you see they are pretty similar. And this, of course, is to be expected, since now we do the prediction on the data we have as a training data. So we did not really separate here training data and test data, which is something you should definitely do when you do this, let's say, for series. So here it tends, obviously, most times to overfitting if you are using for testing the same data that you have used for training. This is quite clear. But on the other hand, it also shows you how well your method might really work in the end, or how well it adapts to the data. But of course, this is often prone to overfitting. We can see this, that it doesn't work, for example, or doesn't work so well if we now try to predict the total number of goals from our data. So again, here in the next tab, you see here what I do here. I do a new linear regression model. And instead of the height, what I do here, or what I try here, I try to predict the number of goals by the year of birth. Since we have seen that there is at least a small negative correlation between year of birth and total goals. So we try, maybe we can predict it here. And here again, we do the prediction for, of course, the input is the year. And what we do then is we do a scatter plot again, where we put year against total goals, and we plot in there our prediction. And we compute the root mean square error exactly in the way we did it again. So let's have a look at the outcome in the graphics. You see here again, this is the year of birth and the total number of goals that have been scored by players born in these years. And this is the linear regression predictor that we have. And you see, it, of course, it doesn't fit as well as in the other case. And the root mean square error here is 55, which means, okay, by giving you a specific year, you can, of course, make an error, or the average error that you make in the prediction is 55 goals, which is quite a lot. So if you look at the mean of the data we have, you remember the mean was about 30, 35 goals, and then if you make an error of 55 in your prediction, this is, of course, way too much. So it doesn't work in that way. What you could do to make it better, so your assumption could be, okay, probably linear regression doesn't work so well. Let's try a polynomial regression, for example. So this could be. So we do a nonlinear regression, which is also quite easy if you do this here in this Python notebook. So what we do here is we simply import now for the polynomial linear polynomial regression, we import the library that we need for that. And what we do first is we, of course, have to define now what are the features. So what we do here, we say we want to use a polynomial of a specific degree. Let's try, for example, degree of 2. And we want to put in the values of total goals. And of course, we want to predict it by the year. And we want to treat these features, the year, as a polynomial. Then what we do here is, okay, now let's do the prediction exactly with the data we have. And what we see here then is these parameters of the coefficients of the polynomial regression. And we want to see the scores or the results we achieve with it. And here we do again the same scatter plot, year against total number of goals, but now with a polynomial. Here it's a quadratic regression, and we also compute the mean squared error. And instead of 55, you see it's a bit better. It's 54.93, but only a bit. And here you see the red line. This is our prediction, which is more or less the same or a bit better. And you could try here to increase the degree of the polynomial. You know, increasing the degree also means that it might become more complex and you might have to wait a little bit longer, but it could fit better. But you should try this out on your own. If you look at this collaborative notebook, you can do even more. So we have prepared a few things that you can play around with, so you can closer inspect your data if you want to. This is one of the points we have provided. And another thing we have provided is a multivariate regression. So you can try to include all the other features we have, including normalization of these features, and find out how well you could, with a multivariate regression, probably predict the total number of goals. Simply try it out. Okay, so this was our task of prediction, our hands-on task. For now, we have treated, or we have done several examples, starting with data visualization, then we did data analysis, and now we did also data prediction. In the next parts of the lecture, we do something else, which is also an application of the things we have already learned, and we will start with doing semantic search.